In these problems, we are using the power rule to find the derivatives of more functions. So far, we've looked at some pretty basic functions to apply the power rule to. So for example, we might have looked at 2x cubed, and we learned that we multiply by the power, so this would become 3 times 2 or 6, and then we reduce the power by 1, so 3 minus 1 is 2. So the derivative of 2x cubed is 6x squared. In these problems, we have more than one term, and that shouldn't present too much of a problem because really you just need to apply the power rule to each term successively. The other complication here is that we've got radical signs, cube roots, powers on the bottom of the fractions, and my recommendation with that would be simply to rewrite these as exponents without fractions and without radical signs. So the cube root of t is the same as t to the 1/3. We think about these fractional exponents as the power on top, and this would be t to the first power, and the root on the bottom, cube root there. And then this, of course, 1 over t to the 6 is t to the -6. Now this should be a little easier to apply our power rule to. With the first term, I'm going to multiply by the power, and then I'm going to reduce the power by 1. 1/3 minus 1 is -2/3. And now we've got our plus sign still, we'll leave that. And we've got, actually we won't leave that because this is gonna go negative. We've got -6 times t, so that's -6t. Then we reduce the power by 1, so -6 minus 6t to the -7. This, I think, is a perfectly adequate way to write this. If you wanted to put it back in the form that it was before, this would be, let's see, 1 over 3 times the cube root of t squared. That's the -2/3 power there. Put it on the bottom of the fraction to get the negative, and then this is the 2/3 squared and the cube root. With this one, pretty similar. This would just be -6 over t to the 7th. But you don't have to do that. You can leave it like that, and the answer should be fine. Let's do one more for practice here. Now this looks a little different. We've got what looks like a quotient, and there is a way to take the derivative of a quotient, but we haven't learned it yet. So what we're going to do actually is just divide both of these terms by t. So this is t to the 1/2 divided by t, and I'm going to think of this as t to the first, and it's t to the 3/2 divided by t to the first. And when you're dividing, you subtract the exponents. So the exponent for the first term is 1/2 minus 1, or t to the -1/2. And for the second, 3/2 minus 1 is just 1/2. Now, we haven't taken the derivative. We've just rewritten this expression. This is the same as our initial function g of t here. But now we can apply the power rule. Again, we're going to multiply by the exponent, so -1/2, and then we're going to subtract 1 from the exponent. So that's going to be -3/2. -1/2 minus 1 is -3/2. And the second piece, we multiply by the exponent, 1/2 t. We subtract 1. 1/2 minus 1 is -1/2. And that could be your answer. You could type it in just like that. That's totally fine. If you wanted to put this back into radical form, you could do that too. This would be -1 over 2 times t squared, cube root of t squared. This would be 1 over 2 times the square root of t. But either way would work. So that's a little bit of work with finding some more derivatives using the power rule when we have more than one term.